Number 1. The Salish Sea Severed Feet. On August 20th, 2007, a 12-year-old girl was exploring a beach on Jedediah Island in British Columbia when she picked up a blue and white running shoe. There was a foot still inside it. 6 days later, on August 26th, a second shoe washed ashore on nearby Gabriola Island. There was a foot inside that one too. Both were right feet. They did not belong to the same person, and they were only the beginning. Over the years that followed, more than 20 disarticulated human feet, almost all of them laced into modern athletic shoes, washed up along the Salish Sea. That is the shared body of water linking British Columbia and Washington State, a basin that includes the Strait of Georgia, Puget Sound, and the Strait of Juan de Fuca. It is ringed by Vancouver, Victoria, and Seattle, and it became the strangest crime scene that was never actually a crime scene. 2 separate systems handled the cases. The British Columbia Coroner Service worked the Canadian feet. Washington medical examiners worked the American ones. The public assumed the worst. A serial killer. A dismemberment ring. The truth turned out to be quieter, and in its own way, more unsettling. When a body sinks in cold water, the ankle is one of the first joints to give way. Soft tissue decomposes, scavengers feed, and the foot detaches naturally, no blade required. What changed in recent decades was the shoe. Modern running shoes are built with foam midsoles and sealed pockets of air. They float. So the foot, cushioned and protected inside a buoyant shoe, rises to the surface and drifts while the rest of the body stays down in the dark. Investigators found no cut marks consistent with a knife. DNA testing matched many of the feet to missing people, most of them victims of drownings and suicides. One match in 2008 traced a foot to a man who had jumped from a bridge. There was even a hoax, a shoe stuffed with seaweed and animal bones, that briefly fed the panic. The oceanographer Curtis Ebsmeyer, famous for tracking floating debris, showed how the basin traps and recirculates whatever lands in it. The Salish Sea does not flush its contents out to the open ocean. It holds them, and it returns them, one shoe at a time. And the sea is very selective about what it chooses to give back. Number 2. The North Korean ghost ships. Move from a single foot to an entire crew, and the dread changes shape. Along the western coast of Japan, the side that faces the Asian mainland, a grim kind of vessel keeps arriving. Battered wooden fishing boats, often around 10 meters long, drift in from the sea and run aground on the sand. Inside, many of them are bodies. Frequently, the bodies are reduced to skeletons, which is how these vessels earned their nickname, the Boats of Bones. The numbers are not small. In 2017, Japan's Coast Guard logged a record 104 of these ghost ships, up from 66 the year before. They come ashore most often in the prefectures of Akita, Yamagata, and Ishikawa. The boats are crude and underpowered with no modern navigation equipment, and the markings, nets, and gear aboard point consistently to North Korean fishing operations. The most widely accepted explanation is economic. North Korean fishermen, under pressure to meet state quotas for squid and other catches, pushed farther and farther offshore in boats never meant for distant waters. When storms hit or engines failed, the crews could not get back. The Tsushima Current, which flows northeast through the Sea of Japan, then carried the drifting boats toward Japan like a conveyor belt. The winter monsoon season, from November through March, lines up exactly with the peak of arrivals. Sometimes there are survivors. In 2017, a boat that landed at Oga, in Akita, carried 8 living North Korean fishermen who were later repatriated. But far more often, the boats hold partial remains, severed limbs, scattered personal effects, or crews who clearly died of exposure, starvation, or thirst while adrift. Some vessels were found with bodies deliberately arranged inside the hull, or with crude burials. Japanese authorities photograph each boat, document what they find, and cremate the unidentified, storing the ashes in case a name ever surfaces. Reporting suggests the pressure only grew as sanctions tightened and as fishing rights in some waters were sold off to Chinese fleets, forcing North Korean boats into even more dangerous grounds. The result is a recurring humanitarian tragedy and a quiet diplomatic strain, played out one wreck at a time. These are not the ghost ships of legend. They are real, they are recent, and they keep coming. And not everything the sea delivers is even recognizably human. Number 3, the Pompano Beach Giant Eyeball. On October 10th, 2012, a man named Gino Cavacci was walking along Pompano Beach on Florida's Atlantic coast when he spotted something resting on the sand. It was an eyeball. Not a human eye, but a single, enormous, blue-tinged eyeball, roughly the size of a softball. It was startlingly fresh, intact enough to still hold its perfect spherical shape, with a faint wet sheen across its surface. Kavachi did the sensible thing. He put it on ice and called the Florida Fish and Wildlife Conservation Commission. For more than a week, nobody could say for certain what it was. Speculation ran wild. A giant squid, a whale, some unknown monster of the deep. The commission sent the specimen to its research institute in St. Petersburg, where scientists examined its size, structure, and the bone and tissue still clinging to it. On October 18th, the answer came back. The eye belonged to a swordfish. Swordfish have proportionally massive eyes, and there is a reason for that. They make daily vertical migrations into deep, dark water to hunt, and those large eyes gather every available scrap of light. More remarkable still, swordfish possess a specialized organ that heats their eyes and brain above the surrounding water temperature. Warm eyes work faster and see sharper, giving the fish a hunting edge in the cold gloom where most animals are nearly blind. The blue color of the eyeball was not dye. It came from the structure of the tissue itself and its reflective inner layers. So how did it end up alone on a beach? The investigators noticed something telling. The cuts around the eye were straight and clean, the kind a knife makes, not the ragged tearing of a predator. The most likely story is mundane and a little grim. A fisherman caught a swordfish, cut out the eye, and tossed it overboard, and the current carried it ashore. For comparison, the largest eyes in the entire animal kingdom belong to the colossal squid, measuring up to about 27 centimeters across. A swordfish eye is small by that standard, yet on a sunny Florida beach, it looked like something from another planet. That is the pattern with deep-sea anatomy. Adaptations that make perfect sense in the dark look alien the moment they reach the light, and sometimes the sea does not deliver one strange thing, but thousands of them at once. Number 4. The Drake's Beach Penis Fish Stranding. In December of 2019, visitors to Drake's Beach in California's Point Reyes National Seashore arrived to find the sand carpeted with thousands of pink, glistening, sausage-shaped creatures. The internet gave them an unforgettable name: penis fish. They are not fish at all. They are fat innkeeper worms, a marine spoonworm with the scientific name Urechis caupo, native to the mudflats of the United States West Coast. A naturalist named Kate Montana photographed the scene, and the images went viral after the magazine Bay Nature, and the biologist Ivan Parr explained what had happened. Under normal conditions, you would never see these animals at all. They spend their entire lives, sometimes as long as 25 years, buried in U-shaped or Y-shaped burrows beneath the sand and mud. They feed in an ingenious way, secreting a net of mucus that filters tiny particles of food from the seawater drawn through their tunnels. The name innkeeper comes from the lodgers that share those burrows, including pea crabs, small fish called gobies, scale worms, and clams, all of them taking advantage of the shelter the worm builds. So why were thousands of them suddenly exposed on the open beach? A powerful winter storm. The strong waves and currents scoured away the entire layer of sand that normally hides the worms, stripping their world out from under them and casting them onto the surface. This was not the first time. Similar strandings have hit the California coast before, at places like Pajaro Dunes and Bodega Bay, always after major storms. Ivan Parr's explainer in Bay Nature reassured a worried public that this was not pollution and not some mysterious die-off. It was simply the ocean turning a hidden ecosystem inside out. The worms are an important food source for otters, sharks, rays, gulls, and shorebirds, and in the days after the stranding, the birds moved in to feast. In parts of South Korea and China, related spoonworms are eaten raw as a delicacy called gaibul. For a few days in 2019, an obscure burrowing invertebrate that had existed almost unchanged for millions of years became one of the most famous animals on Earth. It was a vivid reminder that the storm does not just bring things in from far away, sometimes it digs up what was beneath your feet at the whole time. And sometimes, the things that cross the ocean are not alive at all. Number 5. The Tōhoku Tsunami Ghost Debris. On March 11, 2011, a magnitude 9.0 earthquake struck off the coast of Japan and sent a catastrophic tsunami inland, When the water pulled back, it dragged an estimated 5 million tons of debris out into the Pacific Ocean. About 70% of that sank near the coast. But roughly 1.5 million tons stayed afloat and began a slow, eerie journey across the largest ocean on the planet. Carried by the Kuroshio Current and the North Pacific Gyre, the lightest debris reached North America within about a year. The most haunting single object was the Ryu Unmaru, a 50-meter squid fishing vessel torn from its moorings by the tsunami. It drifted across the entire Pacific with no one aboard, a true ghost ship. The United States Coast Guard finally located it off the coast of Alaska, and on April 5, 2012, deliberately sank it with cannon fire because it had become a hazard to navigation. Then, on June 5, 2012, an enormous concrete dock weighing around 100 tons washed ashore at Agate Beach near Newport, Oregon. It had broken loose from the town of Misawa, and it was alive. Clinging to it were an estimated 100 tons of organisms, including potentially invasive species like the northern Pacific sea star and a kelp called wakame. Researchers including John Chapman and James Carlton studied the rafting life, and a 2017 study in the journal Science documented nearly 300 Japanese coastal species that had survived the multi-year crossing by hitchhiking on debris. Other arrivals were heartbreakingly personal. A Harley-Davidson motorcycle sealed inside a white shipping container washed up on Graham Island in British Columbia. It was traced to a man named Ikuo Yokoyama, who had lost family members in the disaster. When Harley-Davidson offered to restore it, he asked instead that it be preserved as a memorial. Soccer balls and a volleyball, with names still written on them, drifted to Alaska and were returned to their owners in Japan. A boat from Rikuzen Takeda High School made the same journey and was sent home. The tsunami had killed somewhere between 18,000 and 20,000 people, and many remained missing, which gave every washed-up object a terrible weight. Noedee set up a marine debris tracking program to predict where things would land. The crossing rewrote the science of how species invade new coastlines, proving that ocean rafting could carry life across an entire ocean. And it proved something darker, too. The sea can carry the belongings of the dead halfway around the world and lay them gently on a stranger's beach. Sometimes, though, it returns the dead themselves. Number 6. Coffins Unearthed by Storm Surge. We bury our dead with the expectation that they will stay buried. The ocean does not always agree. When hurricanes, floods, and king tides push seawater inland, they can rip caskets and human remains straight out of low-lying coastal cemeteries. The most dramatic modern example came with Hurricane Katrina in 2005, when hundreds of caskets and burial vaults floated free across Louisiana. In towns like St. Gabriel, coffins drifted through streets and fields, sometimes carried far from the graves they came from. There's a regional reason this keeps happening in Louisiana. The water table sits so high that many graves are shallow and many burials are placed in above-ground vaults, which makes them especially prone to floating once the water rises. Katrina was not an isolated case. Hurricane Isaac in 2012 dislodged dozens of caskets in the community of Braithwaite. Major flooding in 2016 surfaced caskets yet again, sending in federal and state recovery teams to re-inter the displaced remains. Beyond hurricanes, slow coastal erosion does the same work over time. At Townsend, in Georgia, and along the Outer Banks, the retreating shoreline has exposed old graves and scattered bone at the water's edge. In the United Kingdom, eroding clifftop churchyards have spilled centuries-old skeletons onto the beaches below, and places like the Isles of Scilly have surrendered medieval bones to the surf. Rematching a floated casket to the right grave is often impossible, which leaves remains unidentified all over again. Specialized teams, including the Federal Disaster Mortuary Operational Response Team, known as DMORT, are deployed specifically to recover and document these remains. Because sealed vaults and embalming can preserve a body so well, the caskets that float free sometimes arrive disturbingly intact. The problem is not only modern. Coastal Native American and colonial-era burial grounds have been exposed too, raising difficult legal and cultural questions about who protects the dead. Communities now use beach nourishment and seawalls to defend threatened cemeteries. And investigators turn to GPS and DNA to return floated remains to families. But the deeper meaning is hard to shake. Burial is supposed to be permanent, an ending. Storm surge turns it into something temporary, and the sea reclaims what we thought we had put safely away. Not everything the ocean returns, though. is a horror. Sometimes it delivers a fortune, wrapped in the most unpleasant origin imaginable. Number 7. Ambergris, or floating gold. Imagine walking along a beach, finding a dull, waxy gray boulder, and discovering it is worth more than a house. That is ambergris, and people have called it floating gold for centuries. Ambergris is a solid, waxy substance that forms inside the digestive tract of the sperm whale. Scientists believe it develops around the indigestible beaks of the squid that sperm whales hunt, forming a protective concretion that shields the whale's gut from the sharp, chitinous fragments. Only a small fraction of sperm whales produce it. Once released, it floats. Fresh ambergris is soft, dark, and frankly foul-smelling. But after years, sometimes decades, drifting at sea and slowly oxidizing in sun and salt water, it hardens and transforms into something sweet, musky, and earthy. Lumps range from small fragments to boulders weighing over 50 kilograms. A find in Oman in 2016 weighed around 80 kilograms, and large hauls like it have been valued anywhere from hundreds of thousands of dollars to more than $1 million. The value comes from the perfume industry, which prizes a compound in ambergris called ambrane. Ambrane works as a fixative, making a fragrance last far longer on the skin. Beachcombers in the United Kingdom, New Zealand, Oman, and the Maldives have stumbled into sudden fortunes from a single lucky find. But there is a catch, and it depends entirely on where you stand. Because the sperm whale is a protected species, many countries restrict the trade. The United States bans ambergris outright under the Marine Mammal Protection Act and the Endangered Species Act. Yet the United Kingdom and parts of Europe permit trade in naturally beach-cast ambergris, on the logic that no whale was harmed to collect it, so the same lump can be a windfall on one coast and contraband on another. Modern chemistry has produced a synthetic substitute called ambroxan that covers much of the industrial demand, but natural ambergris still commands a premium. To test whether a find is real, collectors use a hot needle. Genuine ambergris melts into a glossy, fragrant resin. The substance has a long history, prized in incense, medicine, and even food across the Islamic world and Europe, and Herman Melville devoted an entire chapter of Moby Dick to the irony of fine perfume born from the decay of a whale. That is the disturbing twist behind the luxury. The most exquisite scent on earth begins as a lump of gut matter wrapped around the beaks of devoured squid, and sometimes the sea delivers beauty and danger together in the same surreal tide. Number 8. The Velella and Blue Dragon Mass, Strandings. Some mornings, a beach turns electric blue overnight. The cause is a creature called Velella, the by-the-wind sailor. It is a small, cobalt blue organism that floats on the surface of the open ocean, carried along by a stiff triangular sail that rises from its body. Despite its appearance, it is not a true jellyfish. It is a colonial hydroid, a relative of the Portuguese man O War. Because the wind pushes directly on that little sail, when the wind turns on shore, it drives these animals in by the millions. Along the United States West Coast in the years 2014 and 2015, massive strandings blanketed beaches from California up through Oregon and Washington. Those events coincided with a notorious marine heatwave in the Northeast Pacific that scientists nicknamed the Blob, which warmed the water and boosted surface drifting life. When Velella strand, they dry into translucent cellophane-like husks, leaving shimmering blue lines stretched along the tide line. They carry stinging cells that are mild to most people, though they can still irritate the eyes and sensitive skin. But Velella often arrive with far more dangerous company. The blue dragon, scientific name Glaucus atlanticus, is a tiny blue sea slug, a nudibranch rarely larger than 3 centimeters that floats upside down on the surface tension of the water. Its blue and silver coloring is a clever camouflage, hiding it from predators looking down from above and up from below. And the blue dragon has a remarkable, frightening trick. It eats venomous siphonophores, including the Portuguese man O War, and it stores their stinging cells inside its own body. By concentrating that stolen venom, the blue dragon can deliver a sting more potent than the creature it ate. It mass strands on beaches in Australia, in South Africa, and at times along the coasts of Texas and Florida, where lifeguards warn beachgoers not to touch them. Even a dead blue dragon can still sting because the stored stinging cells stay active for a time after the animal dies. Both creatures belong to what is sometimes called the blue fleet, the community of surface drifters that the wind herds onto land together. A carpet of millions of them is genuinely beautiful and genuinely hazardous, and within days it can rot in the sun until the whole beach smells of decay. It is the invisible surface of the open ocean dumped wholesale onto the shore, but for sheer dread, nothing washing ashore compares to a whale. Number 9. The exploding whale strandings. On November 12, 1970, the Oregon Highway Division faced a problem on the beach at Florence. A 45-foot sperm whale, weighing around 8 tons, had died and washed ashore, and it was beginning to rot. Their solution has since become legend. They decided to blow it up. Under the direction of an engineer named George Thornton, crews packed roughly half a ton of dynamite against the carcass, reasoning that the blast would vaporize the whale and leave only small scraps for scavengers to clean up. It did not work that way. The explosion hurled enormous chunks of blubber more than a quarter of a mile. One piece crushed a parked Oldsmobile far from the beach. A local reporter named Paul Linman and his cameraman Doug Brazil filmed the whole thing. And decades later, after the humorist Dave Barry wrote about it in 1990, the footage became one of the most shared archival news clips in internet history. No one was seriously hurt, but spectators had to flee a rain of rotting whale, and the beach was left far more littered than before. In 2020, the town finally embraced its strange fame and named a park the Exploding Whale Memorial Park. But whales do not need dynamite to explode. In January of 2004, in the city of Tainan, Taiwan, a 56-ton sperm whale, about 17 meters long, was being transported through the streets toward a research station when it burst on its own. The cause was gas. As a whale decomposes, bacteria generate methane, hydrogen sulfide, ammonia, and carbon dioxide inside the sealed carcass. If the tough skin and blubber hold that pressure in, the body can inflate to a grotesque size and then rupture explosively, spraying blood in organs across the surroundings. That is exactly what happened in Tainan, coating nearby shops and cars. For this reason, marine biologists now deliberately puncture or cut open stranded whales to release the gas safely. The danger is real. In 2013, in the Faroe Islands, a beach sperm whale famously burst as a biologist cut into it, all captured on video. A large dead whale is also a logistical nightmare, too heavy to move and hazardous to leave, which is why crews resort to burial, towing it back out to sea, rendering, or landfill. In 2014, the town of Trout River in Newfoundland watched nervously as a bloated blue whale carcass swelled on its shore, fearing it might detonate. Between the spectacle, the overwhelming stench, and the genuine danger, a stranded whale is one of the most dreaded things the ocean can deliver. And yet the most famous beach arrival of the modern age was not a whale, but something nobody could name at all. Number 10. The Montauk Monster. In late July of 2008, a small group of friends walking near Ditch Plains Beach on the eastern tip of Long Island, New York, came across a carcass at the waterline. It was unlike anything they recognized. The body was hairless and bloated, grayish in color with a short, almost beak-like snout and visible clawed limbs. One of them, a woman named Jenna Hewitt, took a photograph, and within days that single image had spread across tabloids and the entire internet. The world wanted to know what it was. Theories poured in. A sea turtle without its shell. A dog. A raccoon. A rodent. And, inevitably, an escaped experiment from the Plum Island Animal Disease Center, a federal research facility located just a few miles offshore, which fueled a wave of conspiracy theories about engineered creatures. The biologists who studied the photographs reached a far more ordinary conclusion. The most likely identity was a raccoon, its features warped almost beyond recognition by decomposition and long immersion in water. That eerie beak was simply the animal's skull, exposed after the soft tissue of the muzzle had rotted away. Water does brutal things to a body. It bloats the tissue, strips away the hair, and lays bare the bone, taking a familiar animal and making it look like a monster. There was, however, a crucial problem. The carcass was never preserved. Accounts say a local resident took it away and then it simply vanished, which meant no DNA test and no proper necropsy was ever possible. The identification however reasonable, could never be formally confirmed. That missing body is the entire reason the legend survives. The Montauk Monster became the defining example of an internet cryptid, a mystery born from an ambiguous, decayed carcass and a chain of custody that broke at the worst moment. Other so-called monsters have surfaced on beaches before and since, and again they have turned out to be bloated, hairless dogs, raccoons, or pigs. Skeptics pointed out that the limb proportions and the teeth matched a raccoon closely. The science that explains nearly all of these cases is taphonomy, the study of how living things decay and fossilize. It is not glamorous, but it solves the riddle almost every time. The Montauk Monster endures not because it is truly unexplained, but because of how easily rot turns the ordinary into the uncanny, and because the public lost the one thing that could have settled it. Which leaves a deeper question. Why does the sea return any of this to us at all? The shoreline is the ocean's sorting machine, and once you see the mechanism behind it, every one of these stories starts to rhyme. The single most important rule is buoyancy. Whatever floats has a chance of coming ashore, and whatever sinks usually does not. A running shoe with foam in its sole floats. A bloated whale carcass floats. A cured lump of ambergris floats. The stiff sail of a by-the-wind sailor floats. Across wildly different objects, the same physical property decides what reaches the beach and what stays lost in the dark. The second rule is transport. Surface currents act as conveyor belts spanning entire oceans. The Tsushima Current carries the ghost boats toward Japan. The Kuroshio Current and the North Pacific Gyre carried tsunami debris to North America. The Gulf Stream sweeps past Florida's swordfish grounds. For the lightest drifters like Velella and the Blue Dragon, the wind itself is the engine, pushing them directly onshore when it turns. The third rule is geography. Semi-enclosed basins, like the Salish Sea and the Sea of Japan, act as traps, holding and recirculating their contents instead of flushing them out. Headlands, pocket beaches, and the places where currents converge become natural collectors, concentrating strandings on particular stretches of coast. Layered on top of those rules is timing. Winter storms scour away sand and expose hidden ecosystems, as they did with the innkeeper worms, and the same storm season drives the ghost boats in. Marine heat waves like the Blob boost the blooms of surface drifters before the wind delivers them. Storm surge and king tides reach inland to lift coffins, and the raw energy of a tsunami can launch millions of tons of debris clear across the planet. Modern materials have changed the equation too. Plastic and foam float longer and protect their cargo better than the wood and leather of a century ago, extending the distance and the time that objects and the life clinging to them can survive at sea. This is why scientists like Curtis Ebbsmeyer can actually model where drifting things will land, and why agencies like NOAA can forecast a debris field's path. The beach, in the end, is an archive the ocean is constantly updating. It does not return everything, it returns what physics allows. And behind that cold machinery lies a very human cost. When something disturbing washes up, a quiet science goes to work turning horror into an answer. The first tool is taphonomy, the study of decay. By reading the patterns of bloating, hair loss, and exposed bone, specialists can recognize that a so-called monster is really a raccoon or a dog transformed by water and time. The second tool is forensic anthropology, paired with DNA matching, which is how the Salish sea feet were tied to specific missing people and how families finally learned what had happened to someone they loved. Coroners and medical examiners coordinate this work, sometimes across national borders, as Canadian and American officials did with the drifting feet. After major disasters, the Federal Disaster Mortuary Operational Response Team recovers and documents displaced human remains. Marine biology labs handle the non-human puzzles. It was the Florida Fish and Wildlife Conservation Commission's Research Institute that identified the giant blue eyeball as a swordfish, using its size, structure, and surrounding tissue. Investigators also learned to distinguish a knife cut from the ragged damage of a scavenger, which is precisely how they read the clean edges around that eyeball, and concluded a fisherman, not a predator, was responsible. Drift modeling lets researchers run the currents backward to estimate where an object began and how long it spent at sea. Specialized tests handle specialized finds, like the hot needle that melts genuine ambergris into fragrant resin and exposes the fakes. Invasion biologists, meanwhile, catalog the living passengers riding tsunami debris, documenting hundreds of species that crossed an ocean alive. Every method has its limits. Without a body, certainty collapses, which is exactly what happened with the lost Montauk carcass, where only a photograph survived. Hoaxes have to be filtered out too, like the shoe packed with seaweed and bones. Sometimes the absence of evidence becomes the evidence itself, as when the lack of any blade marks helped rule out a killer along the Salish Sea. Public communication is part of the science as well. When the penis fish blanketed Drake's Beach, a clear explanation in Bay, nature kept a natural event from spiraling into panic about pollution. And often, the first responder is not a scientist at all, but a beachcomber, a fisherman, or a 12-year-old girl who picks something up and decides to make a call. Strip away the spectacle, and a thread of pure human grief runs through these stories. The Tōhoku tsunami did not just scatter wreckage, it carried the intimate belongings of the dead across an ocean. Soccer balls with children's names, a high school's boat, a motorcycle owned by a man who had lost his family, all of them came ashore on distant coasts and, in several cases, were carried home. Ikwao Yokoyama chose to keep his recovered Harley as a memorial rather than have it restored, a deliberate act of remembrance. The North Korean ghost boats are a humanitarian tragedy measured one skeletal crew at a time, the visible end of an invisible desperation. Along the Salish Sea, the science that sounds so clinical, the DNA, the coroners, the drift models, exists to do something tender. It returns names to anonymous remains and gives families an ending they can hold. The coffins lifted by storm surge carry their own grief, breaking the ritual of burial and forcing communities to gather and reinter their ancestors, sometimes more than once. When the disturbed graves belong to Native American or colonial communities, the questions become cultural and legal as well as personal, asking who has the duty to protect the dead. Remains that cross national borders create diplomatic strain, requiring cooperation between governments that may agree on little else. And there is a psychological weight borne by the people who make these discoveries, the beachcombers and first finders who will never quite forget what the tide brought them. Against all of that, memorialization offers a kind of answer. A park named for an exploding whale, a motorcycle preserved behind glass, a pair of repatriated shoes. These acts insist that the objects mean something, that they are more than morbid curiosities. It is worth being honest about why these stories grip us. Part of it is the thrill of the strange, but a larger part is recognition. In the belongings of the dead and the closure handed to grieving families, we see ourselves, and we are reminded that the sea's deliveries are never really about the sea. They are about us, and the tide that brings them is only going to grow stronger. The forces behind every story in this video are intensifying, which means the coast of the future will receive even more. Rising sea levels push storm surge and high tides farther inland, directly threatening the low-lying cemeteries that already give up their dead during hurricanes. As storms grow stronger and more frequent, coffin displacement events are likely to become more common, not less. Coastal erosion is accelerating worldwide, steadily exposing historic graves and bone along retreating shorelines from Georgia to the cliffs of the United Kingdom. Warming water reshapes the living arrivals too. Marine heat waves like the Blob drive more frequent and more massive strandings of Velella and the rest of the Blue Fleet, while shifting currents change exactly where those drifters and everything else come ashore. Then there is plastic. Durable synthetic debris floats longer than anything nature made on its own, extending float times and effectively building new highways across the ocean for objects and for hitchhiking life. Microplastics are now a permanent fraction of the rack line on nearly every beach, and invasive species increasingly ride that ever more durable debris into new territory, just as they did on the tsunami dock. Economic pressure keeps its own grim momentum. As long as fleets are pushed into dangerous waters, ghost boats will keep arriving. Whale strandings continue to be shaped by shipping, by sonar, and by warming, changing seas. The one hopeful thread is that our tools are improving. Satellite tracking and drift modeling can forecast landfalls earlier than ever, And networks of citizen scientists now log strandings in real time, building a record no single lab could gather alone. The law is evolving too, slowly working out how to treat protected species finds like ambergris, and how to defend threatened cemeteries, whether by armoring the coast or by retreating from it. But the gap between what we can predict and what we can actually prevent is widening. New materials will mean new kinds of debris in the decades ahead, and the shoreline will go on doing what it has always done, only more so. It remains more than ever a barometer of a changing planet. Stand on any beach long enough and you are standing on a border, the permeable edge between the human world and the vast, indifferent ocean. Everything in this video crossed that boundary, and the same handful of forces decided which things made it across. Decay loosened a foot from a body and freed gas inside a whale. Buoyancy lifted a shoe and a carcass and a lump of whale gut to the surface. Current and wind carried them the rest of the way. The ocean is not cruel and it is not kind. It is an archive that keeps what it keeps and returns what it returns entirely on its own schedule, indifferent to whether we are ready. One lesson repeats across every story. Most of the monsters are not monsters at all. They are ordinary things, a raccoon, a worm, a fisherman's discard, transformed by water and time into something that looks impossible. And the line between treasure and horror turns out to be razor thin, separating a priceless lump of ambergris from a coffin adrift in a flooded street by little more than chance and chemistry. There is comfort in the explanations, in knowing that science can take a thing that fills us with dread and hand back an answer. But the explanation never quite erases the unease, and maybe it should not. Because what washes up is, in the end, a message from a place we barely visit. A world that covers most of our planet and shows us almost nothing of itself. Only a sliver ever reaches the sand. The child who picks up a shoe, the beachcomber who lifts a gray boulder, the biologist who leans over a strange carcass. Each one is a witness at that threshold, reading a single line from an archive almost too large to comprehend. The ocean gives and the ocean reclaims, and there is always another tide coming. It is already on its way, carrying whatever it has decided to return next toward the quiet line where two worlds meet.